Shaft. A shaft is a rotating member, usually circular in cross-section, that carries gear, pulleys, sprockets, or rotor and transmits torque. So automatically I explained in my previous video about all this. I'm just making a recap. Axle Axle is a member that supports wheels or pulley but carries no torque. Take note of that. While spindle is just simply a short shaft, named like lion shaft, head shaft, stop shaft, and the rest of it. So shaft, just for you to remember, shaft is twist and transmit. Axle only carries spindle equals short shaft. That's all. Now let's look at torque equation. The torque equation, the general formula, as you can see from the PDF, is this, where uh, this single equation connects stress, load, and deformation. We are going to see that every other formula in this chapter is derived from it, meaning of this each symbol. T is for torque, which is a twisting moment, and it is in Newton meter. But if you work with millimeter, it's Newton millimeter, not per, it's just Newton meter. Why the J is polar moment of inertia of the cross section. The SI unit is m raised to the power 4, right? It measures how the area is spread out around the axis. So let's take the bearings. For example, if you look at bearings, not bearings, the bearing, right? Bearings in wheelbarrow. You see, this guy will now measure how much the stress is being spread across that circular area. So the shape naturally is the shape's natural resistance to twisting. This is what J is all about. While the symbol is this uh, Greek symbol is for shear stress at radius from the center, and it's measured in Newton meters square. Now, radius R, which is the radius, is where you are measuring the stress. This is the radius R is where you are measuring the stress. Maximum at the surface, right? Minimum inside. You have to know that. Now, G is modulus of rigidity. That's the shear modulus of the material, and it's measured in gigapascal, right? It measures how stiff the material is in shear. For steel, we have 80 gigapascal. So it is measuring how stiff the material is. Then theta, angle of twist of the shaft, it is measured in radians. Then L is what the length of the shaft being twisted. So it's very important to know this. In the next video, we are going to look at how to read it intuitively without you stressing yourself.